Hi, I'm Graham Skinner. I'm a well engineering and operations inspector at the Health and Safety Executive. I also sit on the step change in safety, major accident hazard understanding working group. And I've asked Mike Richardson and Willem Boon from Spirit Energy to come and talk about well integrity with us today. So chaps, perhaps you'd like to introduce yourselves.
Hi, I'm Mike Richardson. I'm the Wells TA at Spirit Energy and also sit on the Oil and Gas UK Well Integrity Working Group.
Hi, good morning or good afternoon. My name is Willem Boon. I'm the Well Integrity Principal Engineer at Spirit Energy.
Right, Mike, why is well integrity important?
Yeah, well integrity is very important because the well is the main conduit between the reservoir and the surface. And unless we've got good control of that conduit, we potentially have unlimited source of energy or hydrocarbons flowing to the surface. Unlike surface plant, which contains a finite volume, if a well barrier fails, the leak could continue for days, weeks, months, even years with unlimited volumes. So well integrity has a really big part to play in the way we manage the risk of major accidents and hazards.
And Willem, what would you describe well integrity as?
I think well integrity is the well's ability to contain the reservoir fluids and gas. We call the steel components which make up the well the pressure envelope. And it's this carefully designed steel envelope which prevents fluids from escaping to the environment or other parts of the topside facilities. The pressures are usually, the pressure envelope is usually a combination of casing, packers, tubing, the weld and the Christmas tree, which are designed prior to the drilling of the well and then are designed by the drilling rig. Wells are designed that the wells have two pressure envelopes, i.e. a double barrier approach to prevent the release of hydrocarbons. And this prevention of hydrocarbons is what we call well integrity.
Okay, Mike, what makes well integrity different from other types of integrity that we manage on offshore installations?
Well, I guess there are a couple of significant differences between well integrity and, for example, process integrity. Firstly, pretty obvious, you can't see most of the well, it's in the ground. Whereas you can carry out visual inspections and other external measurements of surface equipment without interfering with normal operations. With wells, most of it's firmly planted in the ground. It's not possible to verify the condition in the same way, really. Secondly, while some parts of the well can be replaced during the life of the well, much of it's permanently installed during the drilling and completion phase when the rig is on site. So we can't change out components as they age and fail in the same way as we can with surface equipment. And we have to monitor them as best we can in situ.
Okay, so Willem, how does that monitoring work? How do you measure this well integrity?
To measure well integrity, we use a series of tests during the well construction phase, which correspond with the main aspects of the well design. And these tests are combined with a continuous monitoring and verification of the well integrity during the operate phase. While the well is being drilled and the installed components are tested, these are then verified by an independent third party. And then during the production phase of the well safety valve and the Christmas tree service elements are tested on a regular basis. We test our safety valves on a 6-monthly basis and the Christmas tree valves and weld components on a 12-monthly interval. And then in addition, there is a continuous monitoring of the pressures at surface of the various pressure containing cavities in the wellbore. We call those the well annuli. The pressure in the analyzer often change when the well is being operated. This is due to the temperature effects when the wells are being produced or shut in. But provided that the pressures remain within a certain defined envelope, no action is required. However, if we see changes in behaviors or when the limits are breached, the well may need to be shut in for further diagnostics. Abnormal pressures and behaviors in the annuli may indicate the degradation of the pressure barrier envelopes that we talked about earlier. As well as the regular testing of the components and the pressure monitoring, we also keep a qualitative record of the external conditions of the well. The wellhead, the conduct and the Christmas tree may have been installed as much as 30 to 40 years and will be exposed to quite a hostile marine environment, which means that certain components may be exposed to oxygen and warm seawater that will lead to severe corrosion.
Okay, so you have to do a lot of interpreting of many different factors. So how do you end up reporting well integrity, and what would you regard as acceptable levels of compliance?
So I guess the process starts with testing procedures. We've got testing procedures which ensure a consistent approach to testing and consistent use of set pass and fail criteria. And we take those results and input them to our well integrity management system, or WIMS as it's known in the industry. Most companies will have something called that, which categorizes any failures in terms of their severity and how urgent our response needs to be. The lowest level of defect, level 1 in our system, has no impact on the safety or integrity of the well. It can be rectified more or less as convenient. The top level, level 5 for us, corresponds to a condition which requires a more immediate assessment of the risk and potentially a prompt repair. Risk assessments and expert reviews, to look at the detail of any failures, are an important part of making sure we are fixing the right things in an efficient way and managing the risk properly. In terms of what's an acceptable level, well, typically data in our WIMS, our well integrity management system, is reported to senior management on a regular basis, and this is really a recognition of the importance of this critical piece of equipment, the well. And in a perfect world, we would have 100% well integrity compliance all the time. But there are sometimes delays in testing, or it takes time to arrange repairs. So it's normal for the well integrity compliance to be a little less than 100%. And sometimes the failure or combination of failures is complex and doesn't fall into a standard classification. And when that happens, these aspects, they need to be considered carefully in specialist risk assessments. It may result in a raising or lowering of the perceived risk level of the well.
That's been really interesting. Thanks very much, Mike. Thanks, Willem.